Hey guys, I'm super excited about this tutorial. We are going to solve a real-world data science problem with Python, Pandas and Plotly. Imagine you are working as a data analyst or data scientist in the 𝗗𝗘𝗦𝗧𝗜𝗢𝗡 corporation, and the CEO wants you to have a look at the commercial data for this year and present any findings you might have. This is essentially what we are going to do in this tutorial. We will turn data into actionable insights. After we have loaded the dataset, we will do some initial exploratory data analysis to get an idea of the dataset. I'm going to show you very useful Pandas functions, which you can apply to any kind of dataset you might deal with. However, nowadays there are so many cool libraries available, which makes our exploratory data analysis so much easier. I will show you my favorite two libraries, which will generate automated reports for us in just a few lines of code. Those reports are a great starting point before we are moving on to answer real-world business-type questions. While answering those questions, we will cover a wide range of various Pandas functions. Additionally, we will also code our own Python helper function, which we are going to use in the deep dive and visualization section. All the charts we are going to create will be interactive and have a clean design. Feel free to code along with me. I have prepared this exercise notebook for you with all the instructions. You will find the download link in the description box down below, so you could watch this video and type the code directly in that exercise notebook. I will of course also upload the solution notebook, which contains all the code we are going to write. Okay, and without further ado, let us get started. Before installing the required libraries for this project, I will create a virtual environment. This is optional, but a virtual environment helps us to isolate different versions and libraries of Python. In simple words, imagine you want to install an old Windows 95 software on Windows 10. There is a high chance that you will face difficulties in the installation process. Also, Python and the Python libraries are continuously developed further. To ensure that your Python script will also work in the future, it is best practice to create a separate virtual environment for each project. I have also created a quick start guide to get you up and running with virtual environments and the Jupyter Notebook as fast as possible. I will link the video in the info card above. If you are using Conda, you can create a virtual environment by typing conda create-n and then the name of the environment. I will call mine data analysis. Feel free to pick any other name. In this environment, I'm going to install Python 3.8. It just happened that when I created this tutorial, I used Python version 3.8. So if you want to make sure that the packages I'm going to use here are also working on your end, I encourage you to also use Python version 3.8. You will be prompted if you want to proceed. Just confirm this by pressing Y on your keyboard. Our virtual environment has now been installed. However, first we need to activate it. You can do this by typing conda activate and then the name of the environment. You will notice now that the name in the brackets has been changed. In the requirements.txt file, you will find the Python libraries we are going to use for this project. Go ahead and type pip install -r requirements.txt. Now this might take some time. Do not get scared if nothing is moving on your screen for a while. As we have created a fresh environment, it has to install a lot of dependencies. Alright, once we've got that out of the way, we can shoot up Jupyter Notebook. In the folder Data, you will find the Excel workbook, which we are going to analyze. The output folder is currently empty. Here we will be exporting the manipulated dataset, as well as all the charts we are going to generate throughout the tutorial. Additionally, you will also find two notebooks. As mentioned already, one notebook which is already fully coded out, and one is so-called code-along notebook. Inside the notebook, I have clustered the main chapters of this tutorial in different sections. You can also navigate to those sections by using the timestamp in the description box down below. First things first, we will import the libraries we have installed previously. Go ahead and import Pandas as PD, import Plotly, import Plotly Express as PX, and from Pandas profiling import profile report, as well as from AutoViz class import the AutoViz class. To execute this cell, you could use shortcut keys. By default, you can run cells by pressing Ctrl and Enter on your keyboard for Windows or Command and Enter on a Mac. Alternatively, you could also click this button here. As you might have noticed already in the imports, I will be using the Plotly library for the data visualizations. Plotly comes already with different styles layout, so-called templates. Feel free to have a look at the different styles and pick your favorite template. I personally like the Plotly white theme. We will store the name of the template in a variable called template style. Later, when we are plotting the different charts, we will be referring to this variable. After declaring the theme variable, I will load the Excel data in a data frame. A data frame simply represents a table of data with rows and columns, just like an Excel worksheet. I will call this data frame df. To load the Excel file, we can use the Pandas method read_Excel, followed by the file location of the Excel file. The Excel file for this project is located in the data folder and it's called data.xlsx. After running this cell, let us print out the first 5 rows of the data frame by typing df.head. Before moving on, let us have a look at the dataset. We've got here the business transactions by order ID for 2020. Each order ID contains further information such as the order date, the shipping mode, product category, sales amount, and so on and so forth. At this point of time, we do not know how many sales records we have in this file or how many different kinds of shipping modes we might have. To dig deeper into this, we will further explore the dataset in the next section. There are plenty of Pandas methods available to explore the dataset. I call those methods the traditional way. I will keep those methods here to a limit as there are already very cool tools available that make the whole process of exploratory data analysis much easier. I will show you those tools in the automated report section. To kick things off, let us get some basic information about the data frame by using the info method. It will return the total number of entries, the column names with their corresponding data time, the count of null values, and much more. For further data manipulation, you want to pay attention to the different data types. Take the order date as an example. In our case, it's already formatted as a datetime. Because of that, we could directly extract the year and month information from the order date by using built-in Pandas functions. Later in this tutorial, I will show you how to do this. On the numerical data types, like integers or floats, we could also apply the describe method to get the summary of the descriptive statistics. It does not make much sense on the row ID or postal code, but if we have a look at the sales, we could already detect an outlier with a maximum sales of 14,000 USD. This also explains why the mean of 221 is much higher than the mode of just $54. As mentioned before, there are plenty of other Pandas methods available to explore your dataset in greater detail, such as checking the unique values for a specific column, or printing out the number of null values for each column. However, to make life easier, we will use automated reports to get a better understanding of our dataset. The first tool will be the Pandas profiling report. To generate the report, we can type profile report and pass over our data frame and a title. To view the report in our Jupyter notebook, we will use the to_widget method. Executing this may take some time, but once done, we get the following report. As I have already a separate video about the Pandas profiling library on my channel, which I will link in the info card, I will not go into great detail here. Nonetheless, I encourage you to explore the available information in this report. In the Variables tab, you will find for each column valuable information depending on the data type. For categorical values like the shipping mode, the report provides you the distinct values as well as a count plot. If you're dealing with numerical values instead, you will get a summary of the descriptive statistics as well as a histogram. The Pandas profiling report generates furthermore correlation heat maps to quickly identify a linear relationship between two variables. To export the report to HTML, you can use the to_file method. Once done, you will have the same report in an HTML format on your local machine. Moving on to the AutoViz library. AutoViz performs automatic visualizations on any dataset. First, I will initiate the AutoViz class. To generate the report, we only need to provide the path to our Excel file. Similar to the Pandas profiling report, it may take some time to run the cell, but once done, you get the following output. AutoViz plots various kinds of charts based on the variables in your dataset. For instance, it will plot the average profit by shipping mode, the average sales, discount and profit by segments, and much more. I highly recommend you to take advantage of those libraries to speed up your exploratory data analysis. In the data preparation and analysis section, we will sharpen our Pandas skills by answering the following questions. Starting with the highest sales in 2020. To find out the highest sales, I will use the nLargest function and specify the column name. In our case, we want to find the highest value in the sales column. After executing the cell, we can see that the highest sales was around 40,000 USD. To find out the average discount of chairs, I will filter first the data frame by using a Boolean mask. Chairs are part of the subcategories. By typing the following statement, Pandas will return for each row in our data frame if the condition we are checking is true or false. In the next step, I will use this mask to filter our data frame. Once we only have the chairs in our data frame, I go ahead and further narrow down the data frame by selecting the discount column. Now we can get the mean of the discount column, which is around 16.7%. In our current dataset, we have one column with the order date, which contains the year, the month, and the date information. Let us have a look at how to separate the year and month from the order date and store those values in a separate column. As we have seen at the beginning of this tutorial, the order date is already in a datetime format. This allows us to use the built-in Pandas functions to manipulate the dates. I will store the year information in a new column called order date year. To extract the year, we can type dt.year. Likewise, I will also do the same for the month. Let us print out the head to check if this worked. And fair enough, we have our two new columns in the data frame. I will expand our data frame by one more column to calculate the profit margin. As for now, we only have the absolute sales and profit amount. To calculate the profit margin for each sales record, I will divide the profit by sales. As a result, a new column has been added. Taking the example of the first row, the generated sales and the corresponding profit are resulting in a profit margin of around 35%. Once we are done with the data frame manipulation, we could also export it back to Excel. Similar to the read Excel method, Pandas also provides the toExcel function. After defining the output path, I will set the index to false as we do not need it. And here's our new Excel file with the columns we have added. Before moving on to the data visualization part, I would like to cover a very handy function in Pandas. As an Excel user, you might be very familiar with the idea of pivot tables to aggregate your data. Pandas also has a pivot method, however, I very often use the group by function instead. Let us imagine you want to get the sales and profit by subcategory. For this, I will use the group by function and store the result in a new data frame called df by subcategory. We will only need to specify the column we want to group by, as well as the aggregation function, which will be the sum in our case. In the new data frame, all numerical values have been now aggregated and grouped by the subcategory. Additionally, the index has been changed to the name of the subcategories. We could also reset the index if we want. Let us shortly refactor those two lines of code by creating a Python function which takes a column name as the input. The function should return the corresponding group by data frame aggregated by the sum. Like above, I would also like to reset the index. We can test this new function by grouping the data by segments. In the next section, we will use this new function to prepare the data for the different kinds of plot. Speaking of those visualizations, in many tutorials you will find the extensive use of matplotlib and seaborn. Those libraries are considered as kind of the standard to-go library for plotting. However, the main part of the exploratory data analysis has been done already with the help of the Pandas profiling and AutoViz library. In this section, we will focus on presentable charts by using the Plotly library. One of the big advantages of Plotly is the interactivities of the charts, which can be very helpful and adds a nice touch to our visualization. The first two charts will be a histogram and a box plot. Both histogram and box plots are used to explore and present the data in an easy and understandable manner. Histograms are preferred to determine the underlying probability distribution of a dataset. Box plots, on the other hand, are more useful when comparing distribution between several datasets. They are less detailed than histograms and take up less space. Before plotting the sales in a histogram, I will shortly get the statistics overview of the sales with the describe method. To create the histogram, all we need to do is to pass over the data frame and the column name in the Plotly Express histogram figure. For the template style, I will use the variable we have set at the beginning of the tutorial. By typing fig.show, we can display the histogram in our notebook. You will notice that there are some outliers in our dataset. However, we can take advantage of the interactivity of the chart and zoom in to any specific area. Creating the box plot is very similar to the histogram. You only need to change the chart type to box. Frankly speaking, this box plot does not look very appealing because of the outliers. That is why I will specify the range for the values in our chart to exclude the outliers. If you hover over the chart, you will also see the stats summary, what we have seen previously with the Pandas describe method. As mentioned already, histograms and box plots are great to show distribution of variables. Bar charts, on the other hand, are used to compare variables, like plotting the sales amount among the subcategories. To get the sales grouped by the subcategories, I will use the Python function we have created earlier and store the data frame in a variable called data. While creating the bar chart, you can notice the similar syntax compared to the histogram and box plot. This time I will also provide a title. A quick tip: you could also use HTML tags in your title to customize it even further. I personally like a bold title. If you want to present this chart to your audience, you could also export it to HTML. With the following line of code, I will store the chart in our output folder. Plotly would automatically open the chart in the new browser window. To suppress the auto-open function, I will set it to false. After running the cell, Plotly has created an HTML file with our interactive bar chart. As the next step, I will also plot the profit by the subcategories. As this is very similar to the sales chart, I will speed up the video a little bit. We only need to swap our y variable to profit and change the title accordingly. What's interesting to notice here is that the sales amount of tables compared to the other subcategories is quite significant. However, it seems that they are losing money by selling tables if we are looking at the profit chart. After exporting this chart to HTML, let us have a closer look at this and combine the sales and profit information in one chart to spot this potential issue easier. In the bar chart, we could also provide the color, which I will set to our profit. The lowest profit should be red, the highest one green, and everything in between should be yellow. We can easily spot that tables are contributing significantly to our overall sales with around 60,000 USD, but generating a negative profit. After also exporting this chart, let us dig deeper into this issue and try to find out the reason for this. With a scatter plot, I will check if there's any linear correlation between the sales or profit and the amount of discount we grant the customer. Similar to the previous chart, we can add a third variable to the chart by setting the color. In our case, I will set the color to the amount of discount. If we zoom in, we could see that a higher discount results in a negative profit. For further analysis, let us check the average discount by subcategory. Also in this case, the group by function will come in handy. I will show you a very cool trick on how you can use different data aggregation methods for individual columns. In a dictionary, we can set the aggregation method for the discount to mean. The profit, on the other hand, should be summed up. This operation might be clearer if we print out the data frame. In this data frame, we have the subcategories as an index. Next to it, the average discount and the total sum of the profit. To visualize the data frame, I will use a bar chart. Remember that I did not reset the index, therefore X will be the index names of our data frame. For the color, I will pick the profit and also provide the respective color scale as seen before. We could interpret the bar chart as follows. It would be wrong to say that a high discount would automatically lead to negative profit. Taking the binders for instance, with an average discount of around 38%. Yet, they still generate a profit of almost 8,000 USD. However, further analysis might be required, which I will not cover in this tutorial. My intention was only to show you different methods and tools to analyze and visualize your data. Last but not least, I would also like to cover line charts and show you some more useful Pandas functions. As we have the order date available, I would like to plot the sales and the profit development over time. To do so, first I will need to sort my data frame by the order date, starting from January and ending in December. Therefore, I will use the sort values method. To double check if this worked, we could print out the head. And fair enough, the first entry of our new data frame starts from January 1st, whereas the last entry is December 13th, which we could check by printing out the tail of the data frame. However, so far we only have the single sales and profit amount for each transaction. To get the cumulative sum, I will create a new column and call it cumulative sales and use the cumSum method. I will do the same for the profit. After running the cell, we can see that those two columns have been added to our data frame. We could also validate this by checking the total sum of our sales, which should be equal to the last entry of the cumulative sales. And it goes without saying, the same should be true for the profit. To plot two lines in one chart, we can provide a list in the y variable, which contains the data for the cumulative sales and profit. And here's our line chart, where we could also toggle on and off the different variables. Okay guys, well done, we have covered a lot in this tutorial. Of course, there is so much more we could have done with the dataset, and I highly encourage you to explore it for yourself. For instance, in the dataset you also have the information on the geolocation for each transaction. This might be also a very cool insight, and you could plot different variables like the sales or discount in a map. On my channel I have also created a playlist where you can find more examples of different chart types and customization options. Perhaps you might want to check it out. I will link the playlist in the info card above. As always, if you have any questions, need further support, or if you are stuck at some point, just let me know in the comment sections down below. I will be very happy to help you out. Thank you very much for watching and see you next time.